Welcome to another deep dive, and this time we're going to be exploring a fascinating figure, a guy named Walther Nernst.
Walther Nernst.
You might not recognize the name immediately,
Right.
but I guarantee you his work has had a huge impact on the tech we use every day.
Absolutely.
We're looking at an essay by Jürgen Koch-Schneeppert, and he makes this bold claim. Nernst, who was a pioneer of thermodynamics, actually had a massive influence on, get this, quantum technology.
Yeah. It's amazing.
We're talking lasers,
Yeah.
superconductors, even quantum computers.
All from research on, things like entropy, absolute zero, that kind of thing. It's a really fascinating connection that Schneeppert makes.
So before we get into the nitty-gritty, let's start with Nernst himself.
Okay.
Schneeppert kind of paints this picture of him being born, like right in the thick of it. 1864, Industrial Revolution, booming, new discoveries all over the place. What a time to be alive.
Oh, I can only imagine.
Can you imagine the energy, the innovation?
It was a time of just massive upheaval in science, and Nernst was right there in the middle of it all.
Schneeppert also mentions that Nernst had some pretty awesome mentors, too.
Oh, yeah.
People like Ludwig Boltzmann, who was a pioneer in statistical mechanics.
Right.
So for those of us who haven't opened a physics textbook in a while, what exactly is statistical mechanics?
So think about it like this. Imagine you're trying to predict the weather, right? You can't track every single little air molecule, so you use statistical methods to look at the overall behavior of the whole system, right?
Okay.
Statistical mechanics is kind of the same idea. Instead of weather patterns, it's looking at how tons and tons of atoms and molecules behave.
So it's like zooming out to see the big picture, but knowing that it's all these tiny things, all these little particles interacting.
Exactly. And it's super important because this was really foundational for Nernst's own big breakthrough,
Which was?
the Nernst heat theorem, which later became known as the third law of thermodynamics.
Okay, the third law of thermodynamics.
Yeah.
This is where things start to get a little, maybe a little head scratchy for some people.
Yeah.
I remember learning about entropy back in school, but a little refresher would be great.
All right, so entropy. It's basically a measure of disorder.
Okay.
Imagine a library. A perfectly organized library, all the books in order, nice and neat. That's low entropy.
Okay.
Now, imagine that same library after a tornado rips through it.
Oh, no.
Total chaos. Right. Books everywhere, totally random. That's
Yeah.
HIGH entropy.
Okay.
Things are more chaotic, less predictable.
Gotcha.
So the third law states that as you get closer and closer to absolute zero, that's negative 273.15 degrees Celsius, the coldest possible temperature, the entropy of a perfect crystal, like it approaches zero.
So as things get colder, they become more ordered.
Exactly. And it's not just some theoretical thing either. This has huge implications for things like cryogenics.
Cryogenics, that's where scientists work with materials at those crazy low temperatures, right?
Right, and Schneeppert actually talks about that connection in the essay. He says Nernst's work was really crucial for understanding how to manipulate and study materials in those extreme conditions.
Makes sense.
Yeah.
If you're going to develop, say, superconducting materials, the ones with zero electrical resistance, got to understand how they behave at those crazy low temps.
Exactly. That's exactly what Nernst's work helped to do, laid the groundwork for it.
So we've got Nernst, brilliant mind, delving into this world of thermodynamics, figures out these big things like entropy and absolute zero.
Yep.
But how does all this connect to the quantum world?
Yeah, right.
Schneeppert makes a pretty wild claim that Nernst's research paved the way for quantum mechanics itself.
And he has some really cool evidence to back it up. So Nernst was doing all of this research before quantum mechanics was even really a thing.
Oh, wow.
But his discoveries ended up being some of the earliest experimental proof for quantum theory. It's like he was accidentally laying the foundation for this huge revolution in physics.
Wait, so he's making discoveries that support a theory that doesn't even exist yet.
Pretty much.
That's mind-blowing.
It really is. One of the key things from his heat theorem was this idea that energy levels are quantized.
Right.
What that means is energy doesn't exist on this smooth continuum like a ramp. It exists in these little steps, like a staircase.
Okay, I'm picturing that staircase in my head. But what's so important about that? Why does it matter that energy comes in these, like, little packets?
That's where the whole quantum revolution begins. That idea that energy is quantized. It's fundamental to how atoms and molecules behave. It explains things like why atoms emit light at specific wavelengths. It's the basis for things like lasers, which rely on those discrete energy levels.
So because of Nernst, we can have laser pointers, barcode scanners, even laser eye surgery.
Exactly.
That's incredible.
And that's just the beginning. Remember, we were talking about superconductors.
Yeah.
Those rely on quantized energy levels of electrons to get that zero resistance. And again, Nernst's work was key to understanding all of that.
It's amazing to think about, right?
Yeah.
Nernst working on these seemingly really abstract concepts, and they end up having this ripple effect across like all these different fields.
Yeah. It really highlights that interconnected nature of science. You never know where a seemingly small discovery will lead. And Nernst, as Schneppet points out, was a master at connecting these seemingly disparate pieces of the scientific puzzle.
So he wasn't just brilliant in isolation.
Right.
Schneppert describes him as this master collaborator, working with some of the biggest names in physics at the time. We're talking Max Planck, the father of quantum theory, even Albert Einstein. What came out of these collaborations?
Well, for one thing, Nernst's experiments on heat capacity, which is basically how much heat a substance can absorb, that actually helped to confirm Planck's quantum theory, which was revolutionary at the time.
Yeah.
So he was providing the experimental data to back up that groundbreaking theoretical work.
So they were bouncing ideas off of each other, pushing the boundaries of science together.
Absolutely. And it wasn't just about staying in the theoretical realm either.
Right.
Schneppert points out that Nernst was also passionate about seeing his work have practical applications too.
He wasn't just an ivory tower kind of guy.
Not at all. He was actually really instrumental in developing the first practical incandescent light bulbs, the ones with those tungsten filaments.
Wait, so the light bulbs that lit up our homes for decades,
Oh,
those were a direct result of Nernst's research.
pretty much.
That's amazing. It seems like everywhere you look in modern tech, there's a little bit of Nernst hidden in there somewhere.
It's pretty remarkable, isn't it? And it goes even further. His work is foundational to things like quantum computing.
Oh, wow.
Remember those quantized energy levels we talked about?
Yeah?
Quantum computers use these things called qubits, and they rely on that same concept, the concept that Nernst helped to establish.
So he's helping to pave the way for computers that could be like exponentially more powerful than anything we have today.
Exactly. And then you've got things like nanotechnology, manipulating materials at the atomic level. Often that happens at those crazy low temperatures we were talking about earlier. Again, we're building on the foundations that Nernst laid.
It's really incredible to think that this one scientist, working on what seemed like these very specific, even esoteric concepts, ended up having this huge impact on like how we live, how we work, even how we think about the future.
It really shows the power of fundamental research, and the unexpected ways those discoveries can ripple out and completely transform fields, even shape the course of history.
It's clear that Walther Nernst is way more than just a name in a textbook. His legacy is woven into the fabric of, like, all of modern technology.
Yeah.
But before we get too carried away with the cool things that came from his work, maybe let's take a step back.
Okay.
Let's look at the specifics of his research a little more closely.
That's good.
All right, so Walther Nernst, pretty important guy, we've established that. But what I'm curious about is, like, how he got there. Schneppert spends a good chunk of his essay talking about Nernst's early life, who influenced him, all that stuff. And it really seems like those early experiences played a huge role in, like, shaping his whole approach to science.
Oh, absolutely. Schneppert really makes a point of showing how Nernst's whole journey from his upbringing to, who he studied with, all of it was super important in leading him to these like huge discoveries. It wasn't just like raw genius,
Right. It was this combination of like experiences, influences, that kind of thing.
Exactly.
We talked about him being born during this like crazy time of technological advancement, industrial revolutions in full swing. But what about his actual childhood? What was it about how he grew up that might have like set him on this path?
Well, Schneppert describes his family as being very intellectually engaged, I guess you could say. They put a big emphasis on education, they loved the arts and sciences, and they really encouraged his curiosity from a very young age.
So he wasn't just like surrounded by cool inventions and stuff. He was raised in this environment where learning and like exploring was really valued.
Exactly. And that fostered this, lifelong love of learning in him, this desire to understand the world around him. And it didn't stop there. His academic journey was just as impressive. Schneppert talks about how he studied at some of the most prestigious institutions in all of Europe, places like the University of Würzburg, the Swiss Federal Polytechnic in Zurich. I mean, these were like the places to be for science at the time.
So he was rubbing shoulders with the best of the best. Did Schneppert mention any mentors or professors that like really stood out?
Yeah, one figure who seems to have been really influential was Friedrich Kohlrausch. He was this pioneer in experimental physics, and he was known for being incredibly precise in his measurements, like super meticulous.
Okay.
And he really believed in connecting theory with actual, empirical data.
So not just coming up with ideas, but actually proving them in the lab.
Exactly. And Schneppat suggested that this rigorous approach to experimentation had a huge impact on Nernst's own scientific method. He wasn't content with just, theoretical ideas. He wanted to see things proven through careful observation and measurement.
Makes sense, given all the amazing technology that came out of his work. It wasn't just equations, right?
Right, exactly.
And then, of course, there's Ludwig Boltzmann, the statistical mechanics giant. We talked about him earlier. Schneppat really highlights his influence on Nernst's thinking.
Boltzmann was a real visionary. He instilled in Nernst this idea of understanding big phenomena, the stuff we can see and observe through the lens of microscopic behavior, like how those tiny particles we can't see, how they interact.
Kind of like that weather analogy we were talking about before, right? We
Yeah.
see the clouds, the rain, but it's all driven by these complex interactions happening at a molecular level.
Exactly. And that perspective was key for Nernst's work on thermodynamics later on. It let him see those connections between the abstract world of entropy and the very real world of energy and matter.
So it wasn't just about those individual mentors, but more about the combined influence of their different approaches, ways of thinking.
Yeah, and that's what's so fascinating. Schneppat makes it clear that Nernst was taking in all of these different perspectives, kind of synthesizing them into his own unique approach.
So we've got this, foundation of rigorous experimentation, this understanding of how microscopic behavior drives the big picture.
Yeah.
But was Nernst already doing, groundbreaking stuff before he came up with the third law of thermodynamics?
Oh, yeah, absolutely. Schneppat talks about his early work on things like chemical equilibrium and electrochemistry.
Mm.
In fact, his doctoral thesis was this huge breakthrough in understanding how electrical energy and chemical reactions relate to each other.
So he was already making major contributions to our understanding of, how energy works, even before the third law.
Exactly. And this early work made him like a rising star in the scientific world. It was clear that this guy had a brilliant mind.
Mm.
He had a real knack for tackling those big fundamental questions in chemistry and physics.
It seems like everything, his family's emphasis on learning, those inspiring mentors, even his own early success, it was all building toward that moment when he formulated the third law,
Mm.
like all those pieces falling into place.
Yeah, it's a great example of how scientific breakthroughs rarely just happen out of nowhere. They're usually the result of years of hard work, collaboration, and building on what others have done before. And Nernst, he was deeply involved in all of those things.
What I find really cool, though, is that Schneppat doesn't just paint him as this, brilliant theorist. He also talks about Nernst's passion for the practical stuff. He wasn't just content with figuring out how things worked. He wanted to see his knowledge actually being used in the real world.
Yeah, you're right. And the incandescent light bulb is a perfect example of that. We talked about how his research on chemical reactions and material science played a big part in creating those early bulbs.
Right, those tungsten filaments that could withstand those crazy high temperatures. But how does that connect back to thermodynamics? It seems like kind of a jump from entropy to a light bulb.
Well, remember, Nernst had this deep understanding of how different elements behave at those really high temperatures,
Okay.
and that was essential for figuring out which materials could handle the heat in an incandescent bulb without, melting or breaking.
So he was taking his knowledge of thermodynamics, material properties, all of that, and using it to solve a very real, very practical problem.
Exactly. It's a perfect example of how he bridged that gap between the theory and the application. He wasn't just happy to understand the principles, he wanted to see them make a difference in people's lives. Schneppat really argues that this was one of Nernst's defining characteristics.
Which is pretty incredible if you think about it. The light bulbs that, lit up homes for generations,
Mm.
those came in part from his scientific curiosity.
Yeah, pretty cool.
I know we've focused a lot on the third law and those light bulbs, but Schneppat also talks about Nernst's role in, building up research institutions, fostering collaboration, all that stuff. What can you tell us about that?
Yeah, so that's another really important part of Nernst's legacy that Schneppat highlights. He understood that big scientific challenges, they can't be solved by individuals working alone.
He was a believer in teamwork, bringing people together, different minds, to tackle those big problems.
Absolutely, and he put that belief into action. He had these key leadership roles at the University of Göttingen and later at the University of Berlin. And he was really instrumental in shaping those institutions into these thriving hubs of scientific research.
So he was putting his money where his mouth was, building these spaces where collaboration could actually flourish. But what did that look like in practice? What was so special about these research centers that he helped create?
Well, Schneppet describes how Nernst was really pushing for things like modernizing lab standards, implementing the latest experimental techniques. He knew that to do groundbreaking science, you need the right tools, the right infrastructure.
So state-of-the-art labs, the best equipment, basically giving researchers everything they needed to do their best work.
Exactly. And that paid off big time. Under Nernst's leadership, Göttingen and Berlin, they became home to some of the most sophisticated labs in Europe, and they attracted top talent from all over the world. It was like he was creating this scientific melting pot, bringing in all these different perspectives to tackle the toughest challenges.
It wasn't just about the fancy labs, though, right? It was about fostering that culture of collaboration, that open exchange of ideas. Schnepp makes it clear that Nernst believed in the power of bringing people together, different minds, to spark innovation.
Oh, absolutely. He understood that innovation often comes from unexpected places, from the clash of different viewpoints, people challenging each other's assumptions. And he created these environments where that kind of intellectual cross-pollination could just happen naturally.
It's like he was creating a scientific ecosystem where ideas could flow freely and researchers could build on each other's work.
That's a great way to put it, and it's a model that we still see today. Think about places like Silicon Valley or the Research Triangle in North Carolina. They're all about bringing together bright minds from different disciplines to drive innovation.
So Nernst was kind of ahead of his time in that way, laying the groundwork for how a lot of science gets done today. But it wasn't all just about the theoretical stuff either, right? Schnepp also mentions Nernst's efforts to connect scientific research with real-world applications. He seemed to have this knack for seeing the practical potential in those abstract theories.
Oh, absolutely. He was a big advocate for collaboration between universities and industry.
So he didn't think that scientific discoveries should just stay in the lab.
No way. He believed that they should be turned into real solutions, technologies that could benefit everyone.
Makes sense, considering his work on the light bulb. He seemed to just have this ability to see the connections between fundamental science and, like, tangible applications.
Yeah, he could really see the big picture. Schneppek gives a bunch of examples of Nernst working with companies, especially in chemistry and electrical engineering. They were developing new materials, new tech, always with this focus on using science to solve real-world problems.
It's that mix of intellectual curiosity and practical thinking that makes Nernst such an interesting figure. He wasn't just a genius, he was a leader, a visionary who understood how science could shape the world.
Absolutely, and his vision is still relevant today. Think about all the challenges we're facing: climate change, disease, figuring out sustainable energy. Solving those problems requires not just scientific breakthroughs, but also collaboration between scientists, engineers, policymakers, even business leaders.
So it seems like Nernst's legacy is about more than just his discoveries, right? It's about his approach to science, his belief in collaboration, and his commitment to using scientific knowledge to actually make the world a better place.
Exactly. And as we wrap up our look at Walther Nernst, I think it's important to remember that scientific progress, it's rarely a solo effort.
Right.
It's more like a symphony of ideas, It's a team effort, and it builds on the work of all those who came before.
So before we took a little break, we were talking about Nernst and this really strong belief in scientific collaboration. Schnepp really lays it out in this essay. He talks about how Nernst built these vibrant research hubs that help to advance scientific knowledge across all sorts of disciplines. It was more than just Nernst's brilliance on its own.
Yeah, it really was. Schneffen does a great job of showing how Nernst was this builder. He had this conviction that if you wanted to see those big breakthroughs, you needed teams of people working together. And he wasn't just satisfied with publishing his own stuff.
Right.
He wanted to build these places where those findings, his findings, could be tested and challenged, expanded on, all of that by a whole community of people.
Those bigger than just working with a couple of colleagues.
Oh, yeah, way bigger. Schnepp gives us some really great examples of this. Nernst, he had these key leadership roles, first at Göttingen and then later at the University of Berlin, and he was a driving force in making those institutions into these, real powerhouses of scientific inquiry.
So he was putting his ideas into action. actually building these spaces for collaboration. But what did that look like? What was so special about these places?
Well, Schneppet talks about how Nernst was a huge advocate for modernizing labs, getting the latest equipment, implementing all of the cutting edge experimental methods.
So he knew you can't do groundbreaking science without the right tools.
Exactly. He understood that. And it paid off too. Under Nernst, both Göttingen and Berlin, they became these super sophisticated labs and they started attracting all this amazing talent, you know?
Like a scientific brain drain, everyone wanted to work there.
Exactly. It was like you said, a scientific melting pot, bringing all these different people together, all these different types of expertise to work on some of the biggest challenges.
And it wasn't just about the fancy labs, though, was it? It was also about that culture, that real spirit of collaboration, that open exchange of ideas.
Totally, yeah. Schneppet makes it clear that Nernst was someone who truly believed in bringing people together, different perspectives, to spark new ideas, to push the boundaries of science.
So it was like he was creating like a scientific ecosystem where ideas could flow freely and people could build off each other's work.
That's a perfect way to describe it. And it's something we still see today, too. Think about places like Silicon Valley, right? Or the Research Triangle down in North Carolina.
They're all about that interdisciplinary approach, bringing together bright minds from all different fields to work together.
Absolutely, that's the key. So you could say Nernst was way ahead of his time. He was setting the stage for how a lot of science is done today. And it wasn't just about the theory either. Remember, Schneppet also talked about how Nernst was always looking for ways to connect science with real world applications.
Yeah, he could see the practical potential in these really abstract theories.
He really could, and he was a huge champion for industry and academia working together.
So he didn't think discoveries should just stay locked up in the lab.
Nope, not at all. He believed that they should be turned into real solutions, technologies that could make a real difference.
Like those light bulbs. He had this gift for seeing how scientific knowledge could be used to solve practical problems.
Yeah, that's one of the things that makes Nernst so interesting. Schneppet gives all these examples of him working with different companies, especially in chemistry and electrical engineering. They were developing new materials, new technologies, and it was always about using science to, solve problems.
So he was this mix of like intellectual curiosity
Yeah.
and really practical thinking. It's not always a combination you see, but it was definitely there with Nernst. He was this incredible scientist, but he was also a leader, and he understood how powerful science could be, how it could shape our world.
It's a legacy that's still felt today. Think about it. All the big challenges we're facing, climate change, finding new energy sources, curing diseases. We need breakthroughs, yes, but we also need people from different fields, scientists, engineers, policymakers, everyone working together if we want to solve those problems.
That's a perfect way to put it. Nernst's legacy goes beyond his own discoveries. It's about how he approached science, this belief in collaboration, and this drive to use scientific knowledge to make things better.
Absolutely. And that's a great place to wrap up our deep dive into Walther Nernst. I think, one of the most important takeaways here is that scientific progress, it's rarely a solo act. It's all about people working together, building on what came before.
And Walther Nernst, with that incredible mind, his collaborative spirit, and his passion for applying science, he was a real driving force in pushing science forward. And his work, well, it's still with us today. We see it in the technology we use and the way we approach problems, in that belief that collaboration is key to unlocking new knowledge.
So the next time you turn on a light, get an MRI, or hear about some amazing new advancement in quantum computing, take a moment to remember Walther Nernst. He may not be a household name, but he's there, woven into the fabric of our world.
Couldn't have said it better myself. Thanks for listening.